Hi and welcome to our next level 2 calculus video. In this video we're going to determine the nature of the turning points, which is a flash way of saying we're going to prove whether a turning point is a maximum or a minimum. Right, you remember maximum and minimum turning points are points on the curve where they have zero gradient. You remember maximums go from a positive gradient and it changes into a negative gradient, and a minimum point is a point on the graph where the gradient has changed from negative into positive. Also remember that the gradient rules are equal to 0. Cool, let's get started with example 1. Determine the nature of the turning point for the function y equal to x squared minus 3x plus 5. So our job is to prove whether the turning point is a maximum or a minimum turning point. Right, let's differentiate to get the gradient rule. And let's put the gradient rule equal to 0 because maximum and minimum turning points have a 0 gradient. Let's solve this equation to get x is equal to 1.5. So there's a turning point when x is equal to 1.5. Right, we're going to show you two methods in this video. I'd prefer you just to learn method 1, but some students like to and some teachers teach method 2. So it'll depend on what you prefer. So here's method number 1. We're going to draw the x-axis. We know there's a turning point when x is 1.5. We're going to pick a point on the left-hand side of the turning point, maybe at 1, and we're going to pick a point on the right-hand side of the turning point, maybe at 2. When x is 1, we're going to substitute 1 into the gradient rule. So the gradient is 2x minus 3, so 2 times 1 minus 3 gives a gradient of negative 1. Now a negative gradient means it's coming downhill. Now let's move to the other side of the turning point, and when x is 2, let's substitute 2 into the gradient rule. So 2 times 2 minus 3 is 1, which is positive, and so we have a positive gradient on the other side. So that means we're going from a negative gradient to a positive gradient, which proves that when x is 1.5, it must be a minimum turning point. Right, example 2. Determine the nature of the turning points for the function y equal to x cubed minus 4x squared plus 3x plus 1. All right, first thing to do is to differentiate the function and get the gradient rule. Then we're going to put the gradient rule equal to 0 because turning points have a 0 gradient. This is a quadratic equation, so we must go back and practice using the quadratic formula or our calculator and solve to get two solutions. X is 0.45 and x is 2.22. One of them's a maximum, one of them's a min, I assume. So the turning points occur at 0.45 and 2.22. Right, here's method number 2. You don't have to learn this new method. Go back and look at method 1, use it throughout the whole exam. But if you want to or have to learn method 2, let's move on to method 2. We're going to take the first derivative, the first gradient rule, and we're going to differentiate again. So we're going to work out the gradient of the gradient, the second derivative, y double dash. So the 3x squared differentiates to 6x, the minus 8x differentiates to minus 8, and the plus 3 differentiates to 0. So this is our second derivative. Now we're going to take the two turning points, the one at 0.45 and the one at 2.22, and we're going to substitute those numbers into the second derivative, the gradient, the y double dash rule. Now you're going to have to remember this box. If the second derivative, f double dash, is greater than 0, we have a minimum turning point. But if the second derivative is less than 0, we have a maximum turning point. So looking at this here, when x is 0.45, we have a negative value, which means it's a maximum. And when x is 2.22, we have a positive number, which means it's a minimum. So looking at the graph now, we've just shown when x is 0.45, it's a max, and when x is 2.22, we have a minimum. Great, thanks for watching.